Okay, in this video we're going to answer questions 9, 10, 11, and 12. There's a fair bit to questions 9, 10, and 11, 12, so this will be a bit ambitious. Stick with us. It says classify maleic acid, hydrogen maleate ion, carbonic acid, hydrogen carbonate ion, and carbonate ion as organic or inorganic, and as acids, bases, or amphiprotic. Then 10 says calculate the molar enthalpy of formation of maleic acid. And it says for 11, maleic acid is made from benzene. Determine if the half reaction of benzene to maleic acid is an oxidation or reduction reaction. Are electrons gained or lost by benzene? Is benzene a reducing agent or an oxidizing agent? And then finally, draw two repeating units of the polymer that would be made if maleic acid was to undergo a polymerization reaction with ethane 1,2-diol. What would the other product of this reaction be? What kind of polymer would be made? That's a lot. Here, I'm asked to identify whether they're organic molecules or not. And so this is a very common question. Any carbonate is not an organic molecule. Same with carbon dioxide and cyanides. So if you get a cyanide, carbon dioxide, or carbonates, they're never organic. So those things are not organic. These are inorganic. These are organic acids. This is a diprotic acid. So this is diprotic. So is this, because they have two hydrogens available to donate. These are both amphiprotic. So this has a negative charge and so does this, so they can both accept a hydrogen, but they have this acidic hydrogen to donate. Finally, the carbonate ion is a diprotic base. It can accept two hydrogens, right? Now, if I had these two substances, this would be a buffer solution. If I had these two substances, they'd make a buffer solution. If I had these two substances in a solution, they'd make a buffer solution. And buffer solutions typically have about equal amounts of those things. So comparably, the same number of same chemical amount of the weak base and its conjugate weak acid. Okay, the next question says to calculate the molar enthalpy of formation of maleic acid. Now, so I've condensed the maleic acid formula here. I've been writing it like this for most of the questions. And there are 4 hydrogens, 4 oxygens, and 4 carbons. And so I've written the balanced combustion reaction for maleic acid because we have its molar enthalpy of combustion. So it's negative 1,355 kilojoule per mole of maleic acid. Since I have 1 mole of this, this is the enthalpy for this combustion reaction. Now, because I know that, and I know Hess's law using formation enthalpies, I can calculate this formation enthalpy using this. So this is going to be a little bit of a slog, but this value is negative 1,355 kilojoules. It's going to be equal to 4 mole times negative 393.5 kilojoule per mole, and that's the formation enthalpy of water vapor, or carbon dioxide here, plus 2 mole times the formation enthalpy of negative 241.8 kilojoule per mole for my water vapor. So I'm subtracting the product, or I've got the products minus the reactants. Now I want to find this. So it's minus 1 mole times the formation enthalpy of C4H4O4. Okay, so that's what I want to find, plus 5 mole times the formation enthalpy of oxygen, which is 0. So if I condense this down, I'm going to end up getting negative 1,355 kilojoules equals negative 1,574 kilojoules, that's 4 mole times negative 393.5 kilojoule per mole, minus 483.6 kilojoules, that's 2 mole times negative 241.8 kilojoule per mole, minus the formation enthalpy of maleic acid. So I simplify this down, or I collect terms, and I get 702.6 kilojoules equals the negative formation enthalpy of maleic acid. And so the formation enthalpy of maleic acid is going to be negative 702.6 kilojoule, and that's for 1 mole of this. So that's per 1 mole, so that is the molar enthalpy of formation, because the coefficient here was 1, right? Because this is a 1, the enthalpy for that formation is going to be 1. Okay? Now, the next question says maleic acid is made from benzene. Determine if the half reaction of benzene to maleic acid is an oxidation or reduction reaction. Are electrons gained or lost by benzene? Is benzene a reducing agent or an oxidizing agent? So we're really trying to get all of those definitions. So I am going to need to do, sorry, I should do this as the redox. So my redox reaction, I've got benzene, C6H6, becomes C4H4O4. Now, there are 2 approaches that I can have for this. I can do it as a half reaction, so I'm going to balance my carbons. So the lowest common multiple is 12, so I'm going to get 2 and 3. That gives me 12 hydrogens and 12 hydrogens, but I've got 4 times 3, I've got 12 oxygens. So I need to add 12 waters, because I use my water to balance the oxygens. Now I've got 24 plus 12, so I have 36 hydrogens. I need to add 24 hydrogen ions to this side, because I've got 3 times 4, so I've got 12 plus 24 is 36. 24 plus 12 is 36. So now everything's equal but charge, so I'm going to have 24 electrons for this half reaction. It's a bit dumb looking. But because I see that there are products, this is Leo Ra, so I know that benzene is being oxidized. It is the reducing agent. So I said there are 2 ways I could figure out whether it's Leo or Ger. I could also have done it using oxidation numbers. So here, hydrogen is a +1. I've got 6 +1s, so I've got 6 carbons. They must each be -1. Oxygens are a -2. Hydrogens are a +1. The carbons here will also be a +1. So my carbon going from -1 to +1 is Leo, so it's the Ra. Now, because they didn't ask me for the number of electrons being transferred, this honestly I think is an easier way to do it than this. If they wanted the electrons transferred, this would work. I could do this as well, figuring it out, but I'd have to do a little bit more math. Okay, so that gets us to the last question for these maleic acid questions, and it says draw 2 repeating units of the product of maleic acid and 1,2 or ethane 1,2-diol. So I've got my maleic acid and this. And what this is going to do, so first of all, this is going to make an polyester, and polyesters are formed when it takes the hydroxyl and a hydrogen and it makes an ester bond. It's going to do that on this end, it'll do it on this end and at this end. So I'm going to get repeating units of this with this, followed by another one of these and another one of these. So if I start off, I go HOOC, CH, CH, COO, CH2, CH2, and then this is going to bond to one of these. So it's going to pull off this hydroxyl, and this hydrogen will react to make C, or OOC, CH, CH, COO, and then it's going to bond to here, CH2, CH2O. And this is how it continues going on. It keeps making ester bonds between this and then this, and it just keeps making a big link. So that's a polyester. And my repeating units here are going to go like this, right? That'll be a repetition. So that's how we would figure out what the product would be. But the other thing that's being made is I'm removing a water each time. So every linkage yields one more water. And that water is going to be present, and we call this a condensation reaction. When you get water as a byproduct from a reaction, they're called a condensation reaction, perhaps a condensation polymer. Those were mentioned in another video as well. So that's different than addition polymers. Addition polymers are where you've got alkenes reacting in repetitions.